Okay. And so I want to start this up, and I want to start this up going over stuff that we've kind of already gone to talk about. Let me move my camera. Let me move my view. Should put that on silent. I can do that. So let's look. I want to take just this basic parent formula, y equals root x, and I want to move it up, down, up 2, down 2. So there are 3 different, and then I want to move it right 3 and left 3. And I want to go ahead and do that. Should not take y'all too long, hopefully. I think I also want to make it a little. So I also like want to think about a table. Like what sort of table, if you're graphing this thing, like what would you think about, hopefully? So make sure we get these parent functions down.
Real quick, Mr. Viz, are you asking for the equations, or are you asking like the numbers for the table?
Yeah, just a few numbers that you would fill out a table with here. Like there's a few numbers you should probably really have. But
I guess like 0, 0 or 1, 1.
0, 0 is absolutely the first thing I would have in my table.
Right.
Exactly.
The one thing they all have in common.
0, 0, and then what would be the next thing? I'd plug in 1 probably.
1, 1.
Make sure I get that 1, 1. So I don't have anything to the left of this, right? I like all my things over here are negative. I can't plug in anything over there. 0 is kind of the first point, right? It's kind of like where it starts almost. Is where you're going to start drawing it for sure, hopefully. It's like your first point you're going to put down, and you can go bloop. Remember this guy looks something like that?
Yeah.
Yeah. And so hopefully 0, 0 is the first thing you put down, 1, 1, and then I'm going to pick some really easy points like what? 4 and
9, 3.
9, yeah, and because that's going to give me what, 2 and 3 if I square root them. So pick even squares. So knowing this sort of pattern will really help you graph this thing. And that's the parent function. So if we want to take this function and we want to move it up to, what does that look like?
Would be the equation, except you space it out and add 2.
So we take the equation, and where does the 2 get added? Is it inside or outside?
Outside.
So definitely make it outside of the square root. Make sure that thing ends. If I want to move it down 2, hopefully this is kind of straightforward. If we know up 2 is plus 2, down 2 is obviously got to be
Minus 2.
minus 2. So those two, once you get one, the other one should hopefully be straightforward. This, I want to move it right 3. So y equals?
X inside plus 3.
There's an x on in the inside. It should be what?
Plus 3.
I can't hear it. You like keep fading out.
The microphone messed up again.
Is it minus or plus? What'd you say?
I said +3.
It should be
-3. That's the one thing.
-3. This is the one that's backwards from what you're thinking.
Right.
So this looks like square root of x -3. This one fills out itself after you do that. It's backwards from what you're thinking. You're thinking left 3. Oh, I'm going to subtract 3. No. +3. So this one is the one that's sort of backwards. When we do things on the inside of the function, we have to kind of back solve for our x. It's going to end up reversing things, so to speak, right? Okay. We got those two. And then there's two things. If I want to flip about the x or flip about the y axis, but if I'm flipping about the x-axis or flipping about the y-axis, I'll give y'all just a minute to think about this. Still doing a root x. Okay, so if we're flipping about the x-axis, what quantities are we flipping? And that might be a weird way to word it, but that's the way I think about it.
Here. It's gonna be on like the end. It's gonna be on the left-hand side. Oh. Wait.
So what quantity would this be that I'm swapping if I'm going this way?
Y values.
It would be the y values that get changed. So if I'm flipping about the x-axis, I want to change my y values or flip my y values. So if I want to flip the y, do I put it on the inside of that thing or do I put it on the outside is the question.
Outside.
All I heard was side. It's like it keeps fading on the important word, man.
I said outside.
It should be.
Okay.
This is
Yeah,
like,
my microphone's all kinds of messed up.
man, yeah, it happens. And like, I mean, I don't think Zoom is the best quality. Don't tell them I said that, but I think it fades a lot, to be honest. It's not the best.
Facts.
I'm not sure there is a best quality, to be honest. There, I don't really know what it would be, but sometimes you gotta adapt. I'm not really sure what to say on that. There's not a lot of options. So we flip the y-axis or flip about the y-axis. This is going to be the same thing. If we're flipping about the y-axis, we're swapping from left to right. We're swapping the x values. And so you could probably do the power of deduction. If this one's on the outside, this one's going to be on the inside. Yeah, so that guy should be on the inside. We're swapping the x values. It should be directly on that x guy. Okay. So that is basically a sort of review of the 6 things that we did previously. The thing that we added to that was scaling. We're going to either shrink things or stretch things. So we have a few examples. They say use transformations to explain how the graph can be solved from the parent functions of the square root of the square function or the absolute value. They say you don't need, we're going to graph these things. I don't know what else. We're definitely going to graph these things. So if you want to spend a few minutes, I think 53 and 54 are pretty straightforward, hopefully. I want you to spend a minute thinking about 53 and 54, and then we will graph them pretty shortly. So hopefully getting on these things.
So Matt, I just want to I want to just say one thing, and you may have said this, I was kind of not paying attention, but when you're doing these transformations, the very first thing, if there's multiple transformations, is the horizontal shift, and the very last thing always is the vertical shift. Otherwise, you can mess up.
I don't think they tell them the order to do it.
They don't, but it is
61,
important.
huh?
It is important when it's real important, especially that vertical shift needs to be last.
Mm-hmm. Yeah, because if you do a flip and then you do a vertical shift, you have to do the flip first.
Yeah, it's important.
But the horizontal flips, I'm trying to think of the way those confuse me, to be honest.
Yeah,
Doing horizontal flips and doing the shifts at the same time.
Yeah, if you
everything's
do
backwards.
Yeah, if you do the horizontal, if you make sure to always do the horizontal shift first, and then it doesn't matter the reflections and the vertical stretching, and then the vertical shift last, you'll be in good shape.
I feel like if it gets more than if it gets 3 or more things on it, I'm probably gonna go throw it into some Desmos. Just being honest about that one.
Yeah.
That's too much to do by hand. I'm gonna mess something up here. Let the machine check me. But I feel like these are pretty straightforward. They have 1 or 2. We're gonna combine 2 different things, maybe,
Yeah, they're not too bad. Yeah. Yeah, these don't look bad at all. But like on number 58, for example, I don't think I think people would probably do it in the order that they see it. Mm-hmm. But if they did the vertical shift, if they did the -3, then the question is, you're not really reflecting over the x-axis anymore, right? You're reflecting over
the x plus 3 or something like that, right?
Yeah, you have
to pull it out. You pull
or
up the
no,
negative.
what they do? Yeah,
something.
it gets confusing. So they need to make. Yeah. Anyway.
Okay. All right, so 53, I'm going to ask the easy question, hopefully. What is the parent function of this thing? What is the thing we're starting with?
X minus 3.
It's going to be one of these things. What is the crazy...
Oh, X squared, sorry.
Yeah. And that -3, I think what was probably what you're saying is the first thing that you're going to do to transform this, right? So what does that -3 do to transform this?
Moves it to the left 3 units.
Be careful now. This is a minus.
Right 3?
Because isn't the +1 like the y-axis?
-3 is doing the right 3. The plus
so
one.
this is the same as the square root.
Exactly. If it's
Okay.
happening inside the function, it's going to be backwards from what you think. That's the best sort of way to describe it. And oh man, we didn't do. Yeah, that's right. We didn't do stretching or shrinking inside. So Even when you stretch or shrink, things on the inside are different. We don't do it in this class, but if it's a large number, you're shrinking. If it's a fraction, you're actually growing. So things happen inverse in the inside when you do stretches and shrinks. We don't do them, so you don't have to worry about them. But the -3 goes right 3. The +1 is going to go where?
Do we not do any stretches or shrinks?
Not on the inside. We do them on the outside.
No, okay, right. Okay, gotcha.
But the +1, I was just saying, the +1's going to go where?
Up 1 unit.
Yeah, up. And if I'm thinking about y equals x squared, I guess I can do my little table, but this is my x, this is my y. I'm thinking about moving what, 1. We'll start with 0 maybe, huh? 0, 1, 2. So my regular x squared function is going through what? 0, 0, 1, 1, 2, 4, 3, 9. Okay. And so if I move my x squared and I move it right 3 and up 1, well, if my vertex is at 0, 0, my new vertex should be over here at 3, 1. So if you want to draw, I guess you can draw your original function. Should be going through at 3, 9. I don't know if it is. Not going steep enough. It should really be going there and there. So I'm a little off, but my original parabola looks something like that. And they really kind of emphasize this in the next structure, but like we're hoping you can go right 1, up 1, right 2, up 4, right 3, up 9. We're hoping like this is the sort of pattern you're picking off of this thing. Because once I know I'm going right 3 and up 1, I know this is my new vertex. So I'm moving from here to here. I can do the same thing, right 1, up 1. I know it's reflected about the vertex. So it is symmetric here. I can go right 1, 2, and I can go up 1, 2, 3, 4. I can get this one. So I can go point by point is another way you can do it. If you want to go right 1, 2, 3 and go up 1, that point's moving to there. You can also move this point by point, right 3, up 1. There are a few ways you can get this, but this new one should hopefully have a vertex at 3, 1 now. And it's following this positive square pattern. Over 3, 1. Be over 3, 1, right? So you can look at this thing point by point if you really want. Move it over 3, up 1. You can do it point by point if you really want to draw the original thing. But if you know the square pattern, you can also use that to your advantage. So either way. So that's 53. 54. Sorry if I'm asking this again, but what's my parent function on 54? The parent function is
X squared.
X squared. So we're starting with an X squared function. And what shifts is that making? So the +2 is going to move it left 2 units. And the -3 is going to move it
Down 3.
down 3. So again, if you want to draw a parabola, just a normal parabola, you can do that. I think I'm just going to start with my vertex. I know my vertex starts at 0, 0. If I move that vertex, what, left 2 and then down 3, I'm moving it 1, 2, and down 1, 2, 3. This should be my new vertex. I can go right 1, up 1. I can go left 1, up 1. I can go right 2, up 4.
anything over here. Two or four. Real quick, Mr. Sears,
Uh-huh.
are we supposed to draw the original vertex and then the transformation, or can we just draw out the transformation vertex?
Are you talking about putting this point? Yeah, you don't really need to put that point.
Well, I mean, like the original parabola. Like I know there's like two for graph, the original and the next one. Can we put the
If
next
you
one?
drew this and you drew these points and you drew these points correctly and you drew this parabola correctly, that's really what I'm kind of interested in.
Okay, awesome.
Because if you like I'm saying, if you can get the square pattern, you can go right one, left one, right, up one, right two, left two, and go up four, right? If you know that pattern, you can follow that pattern. Go for it. I don't know. That's what I'm saying.
I hear you. Appreciate it. Just wanted to get that straight.
But if you don't know how to do that, that's going to take a little bit more time shifting it point by point. I feel. I don't know, but I have my parabola pattern down, so it probably all depends on that.
We did it before works.
I mean, like, and this is the thing. Like, I think people think like, because there's structure to math, they don't realize that there's a lot of like sort of ways, and there's a lot of opinions involved in math. Like, and there's a lot of different ways to get the same sort of thing, and people and their biases really sort of come out. Even though we look at math being this rigorous sort of thing, and it's just like facts, right? And it's like, how could anybody disagree with that?
Right.
It's like there's opinions in this stuff. I don't know how to say it, but like I don't remember. There's a Latin phrase that's like, I know a lion by his paw, and there's a story behind that. There's a famous math problem, and it got submitted anonymously, but they still knew the mathematician. I think it was Bernoulli who submitted the proof, and they're like, I know a lion by his paw. Just like by the way the guy wrote his proof, they knew who the guy was. Like. So it's like part of you comes out through this sometimes, and I don't think people realize that. But part of your personality and stuff can come out through the way that you do math, and it's kind of an interesting perspective that I don't think
Good way to put it.
That a lot of people look at. Yeah. So
Give himself away.
A quarter of x plus 1 squared. Ooh, this one's got some new stuff in it. It's got this section stuff. Look at that. Oh, what's my parent function on this one?
Squared.
First thing you recognize, right? Okay. What does that plus 1 do?
It moves it to the left by 1.
Yes. Plus 1, yeah, to the left. What does that 1/4 do?
Doesn't that flip it?
The negative would flip it.
Okay. Especially.
But this is positive, so it should be right side up.
I guess it. I was going to say shift, but that doesn't seem right. I feel like I should know this one.
Is it on the inside or outside is the thing I'm going to ask.
On the outside.
It's definitely on the outside, so this is happening to my y quantities if it's on the outside.
So you move it up.
What happens when I multiply by a fraction? Is it going to get larger or smaller?
Well, looking at the fraction, probably smaller.
Smaller. So what I'm hearing is
Ah.
by a factor of 1/4. So I'm gonna give you a couple minutes to think about this one. I think. Try to draw this thing. I'm gonna give y'all a few minutes. See if you can figure it out.
Yeah.
And I think this one, it might be better to look at your points and try to do this point by point and try to figure out the points that are going to go on the new thing before you graph it. Try to create a table. I think it might be a good way. But there are other ways to look at the points. Okay. So I want to look at this table. I know I'm starting off with the y equals x squared. My y equals x squared looks something like this. And I want to go left one. And so to go left one, and again, my equation looks like +1. So let's try to get this thing down. Try to swallow this sort of thing. I know it says +1, but if I want to go left one, I really need to do what to each of these things?
Subtract 1 from each
I really
x-value.
got to subtract 1. So 0 minus 1, 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 1. So I really want to subtract 1 from each of these things. My y values I'm bringing down the same, so I'm writing these hopefully in a row where they look the same. But I'm going to do a factor of a quarter. So I got to multiply by a quarter, and I probably already gave you like the solution. But like, what am I multiplying by a quarter in this table? What values?
Y values?
It's got to be the y values. This thing is on the, where is it? This thing is on the outside of my square. So if it's on the outside, it's happening to the y values. If it's happening to the y values, it's straightforward. We're just multiplying everything by a quarter like it says in the problem. It's not backwards like the x values. So 0 times a quarter is, I think it's still 0. 1 times a quarter is
A quarter.
quarter. 4 times a quarter is $1. 9 times a quarter is 9 quarters. That's not a pretty thing to graph. But 16 times a quarter is 4. 16 divided by 4 is the same thing. Okay, so this looks like it's got a few points. It looks like it's got probably 3 points that are easy to graph that aren't fractions. So I'm probably going to go for those points. Okay, so I want to do -1, comma 0. I want to do 1, 1. Ooh, I'm not showing it. There you go. And let's see, show them all on one page. Will it work? There we go. There's my points. -1, 0. I know 1, 1 is a point. Do I know? Is there a way to get another point from this thing? Yeah. Should be a parabola. It should be symmetric there.
So the shape of the parabola would not change. It would still have the same dimensions.
We'll look at it in just a second, and then we'll talk about how it changed probably.
Okay.
Going 1, 1. No. Let's regraph this. Another graph. Minus 1, 0 is this point. Helps you to graph the right point. 1, 1 is that point right there. So if I know I'm going 1, 2 here, I'm going 1, 2 here. You've got to be symmetric about that vertex, about the center of your parabola, right? Another one is 3, 4. So 3, 4 is another point. And I know if this is 3, 4, I'm going 1, 2, 3, 4 to get here. I've got to go 1, 2, 3, 4 to get here and keep it symmetric. So it should be looking something like this. And we talked about what it should do. It should be a straight, a vertical straight. And if we're looking at this from like the typical parabola pattern, if this was my typical parabola, this would be the vertex that goes with 1, 2, 1. Regular parabola would be somewhere in here. And so if we look at like what the black and red parabola, how they compare, it's like we took this thing and we put it in a vise or something like that, right? We squished it down.
Right. So it's spread out more. It opened up more.
It's spread out more. It should be a little bit closer to like my axis here, right? It's like squishing it towards the axis. Okay. So that is the first one we had with new material, I think, today, huh? The other two were kind of a review, hopefully. Are we understanding this? I know that these are a little bit difficult, right? But if you do these point by point, and I think that's probably the best way to do it when you have stretches and shrinks, is going to get you there. Start with what you know. And it's like, it can be overwhelming, and you're like, where's the life preserver sometimes? But you start with what you know, you should get to where you can go, right?
Like that.
Okay, so 56 looks like this, 2 times x minus 4 squared. What is my parent function here? I'm not changing it, it's still the x squared. And so what am I doing to this x squared?
Moving it moving it right by 2, and then I guess you're shrinking it by 2?
Right by 4 is the number that's there.
Right, sorry.
Yeah, and then
2 twice by the
2 is that, what happens when you multiply things by 2?
it's no, if it's a fraction, it's smaller. So if it's a whole number, then it has to be bigger. So it would be not enlarging. It'd be growing. Oh, okay, yeah, growing by 2.
Growth. What do they say? Stretch. Stretch is what the book says. Stretch. Stretch by a factor of 2. Whatever you want to say. It's stretching. It's growing by a factor of 2.
Yeah.
Okay. So if we start with our regular old x squared function, 0, 0, 1, 1, we're thinking 2, 4, we're thinking 3, 9. We probably don't need to get
4/16.
Yeah, we don't need that many on this one. I know I want to move it right 4. And then I want to stretch it by a factor of 2, whatever the heck that means. But for my x, how is my x changing? What do I have to do to each of these x quantities?
Sorry, so add 4?
To add, yeah, right 4 would be adding 4. So 0
Right.
plus 4 is going to give me 4. 4 plus 1 is going to give me 5, 6, and 7, I think is what these are going to become. Maybe I can put it over here, right? Add 4 is what we're doing to move right 4. And again, don't let the original thing confuse you. I know the original thing says like minus 4, but when we move it, we're going to do things backwards in our x's. take note that it's backwards, right? We're going to add 4. We know it's right 4. We know going right 4 is going to add 4. But when we pull it from the thing, it's going to look like a minus. So another thing is a factor of 2. So what am I doing to my other numbers that are there? To my y numbers, I am going to do what?
Multiply by 2.
Exactly. So 0 times 2 is 0. 1 times 2 is going to give me 2. 4 times 2 is 8. 9 times 2 is 18. So y is straightforward. It looks like it's being multiplied by 2 in our formula. So we multiply by 2 in our table. Okay. So now these are my new points that I want to graph. If you follow through on this, I think either 4, 0. Hold this down. Get it all on here. I want to do 4, 0. Bada bing. 5, 2. Looks like right in here. I know 6, 8. So I know I'm not graphing them all. I'm going to graph one side and then do some symmetry. And I try to graph 7, 18. I'm already off my graph. So I got 3 points there. Can you get 2 more points? I hope. Hopefully you're looking down center of your parabola. You look at yourself, you say, I go 1 left to get here. I have to go 1 more left. To be symmetric, I go 1, 2. I have to go 1, 2 more for it to be symmetric.
Right, so this is pushing it in more. It's becoming more narrow when you multiply.
You could think of it as like maybe pushing it in like this way, but that's not the way our book thinks about it. They think about this as a stretch. So we're stretching it out like this way.
Yeah. I just mean it's like it's closing, sort of.
Yeah, so normal parabola would be what? 1, 1, 2, 2, 3, 4. It would be like outside of this thing a little bit, right? I think.
Yeah.
It would be a little bit outside of it. So what we're doing is we're like this paper's rubber and we're just taking it and going stretching it that way, right? Stretching it up and down. So if you stretch things up and down, they do become more narrow in this direction typically. Okay. So we have that. The next thing what we're doing is I think they're changing direction a little bit. We got like 3 more problems on here. And so what function are they using for these 3 problems? So let's just get that out of the way. What's my parent function for these next 3 problems?
Well, which one are we on? 57?
57, 58, and 59, I believe is what we're on. Like, what is the parent function? Is it different for any of those?
Square root.
Yeah, so all these should be y equals square root of x. This is our parent. So the first thing when you look at this, I want you to look at this function. I want you to say, what is making this function look funky? What is like making it look ugly or nasty? The thing here that really sticks out to me is the square, right? That's the thing that makes this difficult. And typically it's either going to be a square root, or I think the other thing they do in this chapter is absolute value, right? So that's your original parent function. We want to think about what this thing looks like. We talked about this earlier, but we got 0. We plug in that. Square root of 0 is 0. We plug in 1. We like to pick really nice numbers that we can do even square roots of. 4 and 2, 9 and 3, 34, 25. And then remember, we can't like plug in anything negative into our x's. We can't have negative square roots in the real number system. So these are all sort of things that hopefully come to mind. And I know they're doing function. I think I'm just like swapping to y, like kind of, huh? Kind of swap between my f of x and my y, kind of willy-nilly. But this is 57. I'm doing a negative. I'm doing a square root of x plus 5.
So I guess we start with x and then we subtract 5 from each of the values of x.
Yeah, so if you're doing that, you're gonna start with this table. Is that what you're doing?
Well, yeah.
And that's one way you can subtract 5 from each of these things. I was going to ask first, like, what is your transformation that you're doing? And I think you did it. You're doing the opposite of this, so you're moving it left 5 units is what it sounds like what you're doing. So this is going to move it left 5. What other thing do you see there?
We're gonna flip it along the x-axis.
Yes. So this is on the outside. It is happening to my y quantities if it's on the outside. And if it's on the outside happening to my y quantities, what goes up goes down, what goes down goes up. We're flipping about the x-axis. And I think they say reflect in the book. That's probably a more mathematical correct term. All right, reflect about the x-axis. Okay. So if you want to make a table, you can make a table. You might be able to do this without a table, just kind of knowing what the graph looks like and doing this sort of pattern maybe. But I want to do a table, so I know I've got to reflect this left 5. So I think you already told me I'm going to subtract 5 from each of my x's.
Yeah. So like what I do, so that way I don't have to write a second table, is that I'm going like with the x, I'll put a -5 above the x in this example. Then I'll go around my entire table and I'll write my new values on top of the old ones. So that way you can just write one table.
Yeah, I did this wrong.
I know that's
-5. I did this wrong anyway. I don't know how to subtract 5 anymore. I thought it was 1 by 1 is what I thought it was done. So -5, -4. All on the table, subtract it over. That sounds like a good approach. 9 minus 5 is more math. 4 minus 5 is a -1. 9 minus 5 is 4. 16 minus 5 would give me something like 11. I think I'm already going past what I could probably graph on my paper. Am I doing anything to my y quantities?
Flip
you're
them to negative.
Make everything negative. A -0 is still 0. -1 is a -1. -3. -4. So these are the new points that I am trying to graph. I go -5, 0. I look at -5, 0. I look at -4, -1. I look at -1, -2. And hopefully we see that the same might start looking like 4, -3. And like if I really wanted to graph 11 -4, I guess I can graph it approximately where it would be. But hopefully we see how this thing starts looking like that square root function. But we moved it, what, left 5, and we flipped it. So hopefully you can see what it would look like. And to recap, let's put the original one on there. The original one here, 2. Original thing like that. So what happened is I subtracted 5, moved it left 5, and I flipped it. Ooh. Should I start taking questions like David S. Pumpkins? Any questions? Like that? Should just go with that? Or no? Okay. It is Halloween month. We could go for it. I'm gonna get my pumpkin suit or something. Yes, lots of them. That's probably what you're thinking, right? Okay, so hopefully you don't have any questions. If there are questions, speak now or forever hold your peace. We took that thing, we moved it left 5, we moved it, we flipped it, and so we put a negative on all the y quantities. Okay. Now we have a negative square root of x minus 3. That's our parent function. And what are we doing with this thing?
What are we, 58?
Yeah, we're on 58 now.
Uh,
So hopefully there's 2 things you see there. And there really is one thing we should do before the other, and they don't really tell you.
We'll move down 3 units before we reflect it.
We want to do down 3 before we reflect. I think we want to do things the other way.
Okay, makes sense.
And like y is straightforward. If we were to plug in a number here, like square root of 4, the first thing we do is take the square root of 4 is 2. The first thing we would do is tack on a negative before we start subtracting things, right? And so if that's the way you're going through this, this is minus square root of x minus 3.
Makes sense.
This way makes sense. When we do things the other way, that's when things get crazy. And like that's why I have some of these marked out, because they have multiple things happening to your x quantity. And it gets really kind of hard to keep track of what's happening, to be honest. Things are happening backwards from what you think, and it's like trying to keep your mind straight when things are happening backwards ain't the easiest all the time. So y equals this. This is a flip about. And I think you said it. We're flipping the y quantities here. It's on the outside. So this is a flip about the x-axis. And then we also have to move down 3. Okay. So there are a few ways you can do this. Let's go ahead and let's do a table. 0, 0, 1, 1, 4, 2, 9, 3. This is my original thing. So if I want to flip about the x-axis, what do I have to do to what quantity? So just doing this flip right here is
oh,
going
well,
to
just the y values, because the x values would not change.
yeah. So just the x, y values are going to get what sort of thing attacked to them?
A negative.
They're going to get a negative. So negative 0 is just 0. I'm going to do the changes in red. I think might be a good way to do it. I'm going to tack a negative onto each one of these things. And then I'm going to move it down 3. What is that going to do?
Subtract 3 from each of those.
I'm not doing anything to my x quantities. Those are staying the same. But 0 minus 3 is going to give me 0 minus 3. This is going to give me minus 4, minus 5, and minus 6, I believe. And so I'm doing something like 0 minus 3. So ignore these middle parts probably. These are my points in here. I have 0 minus 3, I have 1 minus 4, I have 4 minus 5, and 9 minus 6. And I got a sneeze. Phew. Whew. Okay. I'm doing 0 minus. I'm doing 1 minus 4. I'm doing 4 minus 5. And I'm doing 9 and minus 6. And we graph these points. Hopefully you can see how this looks like this thing flipped about the x-axis, and then we moved it down 3. Did I do that right? Yeah, flipped about the x. Why am I doing it? Original function look like that. If you flip it about the x-axis and move it down 3, does this look like what you would probably get? Hopefully. That looks like the same thing, right? And if you want to do this point by point, if you wanted to flip this about the x and move it 1, 2, 3 down, flip this about the x and then move it 3 down, that's also another valid way to do it. To draw your original graph and to sort of move it on the graph itself, right? But you got to make sure you're doing it correctly. I don't know what to say on that. Okay, so one last problem. 2 the square root of negative x. Okay. I want to give y'all a little time to like try these on your own. I don't want to just like give away all the good stuff. So you're doing your table. Hopefully you realize this is a square root of x function. Hopefully you notice there are 2 things that we're doing here. I see this negative. What is that negative on? My x or my y?
Y. Sorry, correction.
It's on your X, but
Could be flipped.
Is right there on that x.
what is this line underneath it doing? I don't understand.
Where? What line? What?
On mine, there's like this line underneath the
It's
square
it's
root.
part of the equation below it. It just got cut off. It just got cut off incorrectly.
That's
I'm not
part of
showing that on
that's part of the
yours.
radical that's there. I don't know what you're talking about. Line below.
Because our printouts, the one that we have underneath the square root of X, there's this line, but I suppose that's just redundant. I don't know.
It's just a chop off or something. It got chopped and cropped, and that part didn't get cropped.
Okay.
Probably is what happened. So the negative is going on the x. What about that 2? Where's that 2 going?
It's
On the Y values.
That's going on the y values. I'm gonna give y'all just a minute to figure this out, I think.
Or flipping it over the y-axis. That's what it looks like.
Okay. Did someone ask a question? I had to I was stepped away just for a second. Thought I heard something. Okay. 59. We said we had to negate the x values. So we look over here, our x values look like this. If we're going to do the negative, negative 0 is 0. Negative of 1 is a minus 1. Negative of 4 is a minus 4. And I'm probably going to go up to negative 9. I'm not going to be able to graph much beyond that. So I could do minus 16 if I really wanted to, but I don't have that big a graph. So the other thing is we have to multiply the y quantities by the number 2. So 2 times 0 is still the 0. 2 times 1 is 2. 2 times 2 is 4. And then 2 times 3 is going to give me 6. So these look like graphable points if I got a 10 by 10 plot. Okay. So we're going, let's graph it on this one. Put this on top. This is what I want to graph. These are the points I found. I want to graph 0, 0. Minus 2. I want to go minus 4, comma 4. And minus 9, comma 6. There we go. And I don't know if I talked about it, but this negative is on the x, so we're flipping the x quantities. So this should look like a flip about the y, and this should be a stretch. So we talked about stretches before. This should be a stretch and flip about the y. So our original function, my original sort of function, my square root function. If I want to draw this thing, I plot these points. Does it look like I flipped it about the y and then I stretched this thing up a little bit?
Mm-hmm.
Absolutely. Okay. So pretend like you're doing, I don't know, let's go back to 58 because I think this might be a good example to do it with. Pretend like you're doing 58 on a homework problem and you have absolutely no idea what you're doing, or you know what you're doing a little bit, but you're not sure which one of those to do first. Because if you flip it and then you, or if, where am I at now? If you flip it and then you move it down, it's going to be different than if you move it down and then flip it. I don't know if you tried it out both ways, but it does not come out to the same picture. So pretend like you had no idea what you're doing or what the order of operations on that thing is. And this was a homework. It's not a test. Like, what would you do? You're just kind of lost on which one to do first.
What,
really
59?
let's do 58 as what I'm looking at.
Oh,
Because it's got two operations. If I flip it and I move it down, it's going to be different than if I move it down and then flip it. Those are going to create different pictures. Pretend like you didn't know. I don't have a clue. Which one comes first? What's a good way to check? And I hope y'all do this. Like, I really wish like y'all would do this sort of thing. I don't know.
Well, I guess you graph the parent function first.
Yeah. I'm being super lazy. I don't want to do a lot of work.
Okay.
Like, what's a good way to check this?
We'll use the since the what was it? The x and y values don't change. I guess you could use the
Y'all
-3
do-
and the 1 in
Y'all
front
do
of it.
things way too hard. I'm trying to this is homework, right? I can do anything. I can use anything out there. What would you do?
Google it.
Google's fine. Yeah. I would throw this in Desmos personally. Desmos, you could Google, I guess, some sort of graphing thing, but like graph this, use technology to graph it, use technology to check your answers. Like, I don't know how else to say that, but like, we have homework that is like this stuff is basically a completion grade that we're doing now. And then we have like 2 or 3 problems. Guys, like, we're grading those things like pretty harsh. I don't know how to say it, but like, that's 50% of your homework grade. Like, you can check your solutions on your homework. Like, that's checking your stuff ain't cheating. It's making sure you understand it. So if I want to do this, and I got to do negative square root, so maybe I got to know what square root is. But if I do SQRT, I think is what it is. It brings it up. So if I do a negative x, I got to make sure I'm outside of my square root. Does that look like the picture we had? Hopefully. It should look like that previous thing we drew. Versus, I think the other one is like if I do a negative and then do square root of x. What? If you do it the other way around, I think it comes out to basically this picture if you factor out a negative. That's if we did the other one first, I think. If we do a negative, you have to put parentheses to say shift it down 3 first and then do the flip. So you could fix it maybe a little bit like that. But if you flipped it and then, I mean, if you moved it down 3 and then flipped it, right? It would be up here like that.
It's really a difference in whether you're flipping it over. We usually say like reflecting over the x-axis, but this time you're actually reflecting over x equals to -3, right? So it's a reflection, but it's a vertical reflection, but it's not over the x-axis.
Which would be, if we do distribution, it would be the same thing as square root of x plus 3, I think, right? It's easier to do your distribution on those first, I think, usually. It's kind of weird.
Yeah, it is. It's this, you were right though. This is the one, the blue one is if you didn't do it in the right, order.
Yeah, if you did them in the wrong order, you would get one of these. The blue or the green is the same thing.
Mm-hmm. Mm-hmm.
You want to do the flip before you do the move down.
Right.
And maybe.
If you always keep in mind the vertical shift should always be the last thing you do. That's what I always try to remember.
So if we do the move down and then the flip, it's going to look like the green, right? The purple's the move down. The green would be that thing flipped about the X. So you definitely want to do flip before you do the move down.
Right.
And if you want to check your solutions, like in your homework, like I said, like use technology for these things. Use Desmos, right? Go to Wolfram Alpha. Like, I'm gonna tell you, give you now 2 months probably, but you want to do x squared minus. I want to do minus 5 minus 2x plus 15. Does that give me an even thing?
Oh, that sounds good.
I think that works.
I can't believe you're showing them this.
You can factor this stuff. Like, your technology will do this for you. Oh, that's not an even thing. Okay. I think it might be minus 15.
Yeah.
That's what I was doing.
I use online simplifier and calculators fairly frequently.
Equals 0. We can even plug this into 0. Look, we can even plug this into like 9. We can find anything.
Pretty cool.
The technology's there. Use it. Like, you got to still show steps. You still got to understand the stuff. you can't use this on a test because we're going to have lockdown browser. I'm going to be watching you. And if you're doing this stuff on a test, I know you're using your computer, obviously, right? But you can use this stuff to check your solutions. Like checking your solutions, I don't know. Like some people, like they come into college, they're like, "That's no, it's not cheating. Like you're doing the work that you're supposed to do. You're supposed to understand this, and you got to check to make sure you're doing it correctly." Like
Otherwise, you do a whole you can go through a whole assignment and do everything wrong, and that's no fun.
and if you're getting everything wrong, come talk to us during office hours. We'll set you straight. Okay. They got really weird stuff too in this thing. I don't know if y'all noticed that. Height of the Space Needle times the width of paper. I don't know. Is that a thing? Will it come up?
Oh my goodness, I never knew that.
They don't have width of paper in here. Width of, height of Eiffel Tower. I'm probably spelling that wrong, huh? That's right.
Oh my gosh, that is crazy.
You can type in crazy stuff like that. They got crazy stuff they input in here. They give you an acres. So now we're in square dimensions. You can do times another. It would give you times the height of Hoover Dam. Oh, of Herbert Hoover.
Is that what you meant?
Nah. And
My
we can get
sister-
something in cubic. So you can do crazy stuff and annoy all your friends with numbers if you really want to.
My sister's dog is named Herbert Hoover.
Okay. Technology.
That's awesome.
Okay, so we did a few transformations. There's like one sort of question they ask here: if the graph of y equals f of x undergoes a vertical stretch or shrink to become this graph, do the same graphs have the same x-intercepts, y-intercepts? So I'm going to do a really simple graph. I don't know. It's 3. What would be the point? I got some sort of graph. You can draw straight lines, I guess. But if I'm doing a vertical stretch or a vertical shrink, you can try one of those or the other. My x's here look like -3, 0. I have 0, 4. I have 5 zeros. So if I wanted to put the points in a table, it might look something like that. But if I'm doing a vertical stretch or shrink, am I changing the x values at all? No. But let's do it by a factor of 2. Or you could do it by a factor of a half if you want to shrink it, whatever you want to do. So what does that mean? I'm taking each one of my y values and I'm going to multiply this by 2. So what is this telling me? My -3, 0 is still the same. My 0, 4 becomes like a 0, 8. And this thing is still the same. So when we do vertical stretches or shrinks, we're pulling things out from or away from the x-axis. So what you might notice is things on the x-axis, do they move? Did these move at all?
No.
No. Things on the x-axis are going to stay on the x-axis. Things on the y-axis, are those things going to move?
Yeah, but what about the 2 points that are on the x-axis? Shouldn't those move up?
These two?
Yeah.
They're going to stay the same. So our y quantity is what gets multiplied by 2, right? So when you multiply 0 by 2,
Oh, okay, because 0 by 2 is 0. Okay, okay.
yeah, so it's like we're stretching this thing. It's like we're taking this thing. If it's down, it's going to go further down. If it's up, it's going to go further up. But if it's on the axis itself, it's just staying there. Right? And so like you have a rubber pad and you're on this end and your friend's on this end. And if you pull at the same rate, like that center is going to stay right in the middle, right? We're not going to move our center if you get it exactly the same. So how do they rephrase this? So the things on the x-axis are not going to move. So our x-intercepts are going to stay our x-intercepts. Our y-intercepts, if they're above, they're going to get stretched up, right? If they're below, they're going to get stretched down. So our y-intercept is going to change, and part of that is because our y values are changing. We have to multiply everything by 2. If the y is not 0, it's going to change. Another reason why these don't change is because they're an x-intercept. Our y value is going to be 0. If we multiply by 0 by anything, it's going to stay 0. So our x-intercepts are going to stay x-intercepts. Our y-intercepts will be the things that change. Ms. Watson, do you have any input or any other way to put that maybe?
No, I like that. That's when I'm doing those kinds of, I always do that, just exactly like that.
Yeah, it's a bit of a conceptual question. It makes you think about it for sure.
Oh,
Yeah.
But if it was a fraction like 1/3 or something, wouldn't that then shrink it?
It's going to shrink it. So now let's look. Okay, so let's do a shrink now. Good question. We have it here. We have it here. I got some sort of graph. Let's look at this. So I'm not even going to care too much about my numbers, but I'm going to shrink it. This thing is going to get closer to my axis, right? This thing is going to be exactly the same. We're squishing things towards the axis then. We're either like squishing them towards the axis or we're like pulling them away. But my y-intercept changes, but my x does not. Same thing if we flip about the x-axis, right? If we flip about the x-axis and we are on the axis itself, it's not going to change. These things will. All right, so that is time. That is the last question. If y'all have any questions about anything else, I will be around for office hours. If you have any questions over anything we just did, I will be around after class even. I'm going to hit stop on the record though, I think.